In this video, we are going to look at two strategies to solving equations. Kendra has $6 to spend on comic books. Each comic book costs $3. Solve the equation 3x equals 6 to find the number of comic books x that Kendra can buy. Students can use a visual model to solve the equation. The hanger diagram shown shows each side of the equation as shapes that represent the weights. We see the 3x represented as 3 individual x's on the hanger diagram. We see the 6 ones represented by 6 individual ones on the other side of the balanced hanger diagram. The hanger diagram is balanced, so the weight of each x is shown to balance the weight of 2 ones indicated by the blue circles. The model shows that 1x is equal to 2 ones. This representation is a way for students to see the equation in a visual format to better understand the equation. Students can also use another strategy to solve the same equation about Kendra and the comic books. Students can use inverse operations to solve the equation. Inverse operations is using the opposite operation in order to solve for the missing variable. Students can use division to divide both sides by 3 as the inverse operation of multiplication. When students divide both sides by 3, they will come up with the answer x equals 2, which indicates the number of comic books x that Kendra can buy. We can use the same strategies again to solve another type of equation. An animal rescue group in Africa is taking care of 5 injured baby pixie frogs. They plan to release them back into the wild when they are healthy. Each pixie frog needs its own terrarium. One of the rescue volunteers checks and sees that there are only 3 terrariums. Solve the equation t plus 3 equals 5 to find how many more terrariums T, the rescue center, needs. We again can create a hanger diagram to solve an addition equation. Students can place 1t on the left-hand side of the hanger diagram and 3 individual ones. They also can place on the other side of the hanger diagram 5 ones to represent the equals 5. This will create a balanced hanger diagram. Students can then model, marking out each of the sides to determine the balance of what would be left to represent the t or the variable in the equation. Once students have balanced the equation, they will find that t is equal to 2, so they will need 2 more terrariums for the rescue center. Students can also use inverse operations to solve an addition equation. Students can use the inverse operation of subtraction to solve for a variable in an addition equation. Students can subtract and balance the equation by subtracting both sides by 3. When students subtract 3 from both sides of the equation, they will come up with the answer of t equals 2. Students can use both strategies of hanger models and inverse operations to solve problems with equations.